Hi everyone and welcome to the second part of this video tutorials. In this video we are gonna write a minimal 3D MF importer using CS style interface to parse a resources element, find a mesh object and print out its vertex positions and triangle indices. We are also gonna take a look at 3MF specification chapter 3 and 4 that talks about 3D models and object resources. Okay, so let's go ahead by adding a new class called import 3mf. I'm gonna go ahead and simply add the header files and CPP file. Okay. Alright, so for the header file, the first thing that we have is the namespace called E3D, and this is simply the name of the namespace that we are going to use for all of the classes that we are going to write in this project. Next, our constructor is going to take a string, and this is going to be the absolute path to the 3mf file that we want to load. I also set the destructor to default because pretty much we are not going to do anything special at the moment. So I think default should be good enough. Next thing is we want to make sure that this class is non-copyable. So I'm just going to go ahead and delete the copy constructor and assignment operator. And next function that we have is called read data, and basically this is a simple function that we are going to pass into the constructor to read in 3mf data. Okay, so let's go ahead and write our class declaration in the CPP file. Okay, so inside our read data, there are a few things that needs to happen. The first thing that we need is to create a model and 3mf reader instance. Okay, so to create a model, we simply call lib3mf create model. So we created this p lib3mf model pointer called p model, and we pass it by the pointer to this function. And if you look at the declaration of in the definition of this function, you can simply see that it takes a pointer to another pointer. So let me go ahead and put this header file inside here so we can see things better. As you can see, we have to pass in the address of this p model to create model. After that, we need to create a model reader instance for a specific type, which is in our case 3mf. So if you search for lib3mf model query reader, you can see that the first parameter that we have to pass is a pointer to p model, which pass it here. We also need to have the reader class type, which is a string identifier, and we set it to 3mf. And it also takes a pointer to another pointer, which is lib3mf model reader, which basically do it here. The next thing that we need to do is to read a model from a file. So this can be simply done using this function. It's a lib3mf read from file utf8, and basically we need to pass in again the p3mf reader and the file that we need to load. Okay, we are also checking to make sure that this function is actually successful. We want to make sure the file that we are passing is okay, and for whatever reason there is something wrong with this file or something bad happens, we want to make sure that we are releasing our p model object. Okay, everything and we are returning. If everything goes fine, we just return lib3mf okay. Okay, let me close this. All right, so the next thing that we need to do is in our CMake, we are gonna also include our 3MF app folder in the include path list. So when we use angle brackets, the compiler is gonna search for the files in the include path list. So inside our CMake list, I'm gonna go ahead and include our, first thing I'm gonna do is I'm gonna create a new variable called 3MF app. Okay, and let me just go ahead and copy and paste this. Much easier. All right. So we set this variable and we set this to source directory, source apps 3MF. And the next thing we are gonna do is we are gonna include the directories and pretty much passing this 3app directory path inside here. All right. Okay, so with that, we are gonna go and run our CMake since we added these two new files and see if we can compile. So before doing that, I'm just gonna go ahead and inside our main .cpp, I'm just gonna get rid of this version output that we added in the previous video. So I'm just gonna go ahead and delete this code and I'm just gonna include our import 3mf.h. Okay. Let me just go ahead and use our namespace. So for now, I'm just gonna pass nothing here. I'm sure it's gonna fail, but it's okay. We just wanna make sure that code we have is gonna compile. All right. We come back and change this part. All right. Okay. And let's go to our Visual Studio and just see if we can run our program. Okay, let's go ahead and compile this. Okay, it seems that we are compiling okay, so that's perfect. Now, the next thing that we need to do is we need to create a resources folder to hold that holds our 3MF sample files as well as other resources that we are going to use in later videos, such as shaders or any art assets that we might want to have. Okay, so let me go ahead and inside bash, what I'm gonna do is let's go inside source apps. I'm gonna create a folder called resources, and inside the resources directory I'm gonna create another directory called 3mf. Okay, perfect. Now, the next thing that I'm gonna do is I'm gonna go ahead and copy our cube-based materials.3mf into this folder. So I'm just gonna copy cube base materials.3mf inside here. Okay, and this would be the file that we are going to load in a moment. Now, the next thing that we need to do is we need to find a way in our C++ code to get a hold of these resource folders so we can actually load these 3mf files. The way I'm going to do this is by using the cmake command called add definition. So I'm going to go ahead inside the cmake list, and I'm going to set a resource directory path. Okay, so I'm just going to set this. All right, and I'm going to add the add definition. So I'm just going to add definitions command, and basically what I'm going to do is I'm going to set the resource directory path to be this resource directory path where we actually hold our 3mf data. Okay, now if we go back to our C++ code, I can simply use this resource path to point to the directory where this 3mf file is. All right, so let me go ahead, and we don't need this IO string. Okay, so I'm going to create a new string object, call it res path. I'm going to create this object from resource dir path, and this is the flag that we created inside our cmake. So remember, this is the one that we want to have, we want to use. So I'm just going to use this like this. All right, and the reason I had to create this string object is because later on inside this import 3mf I need to append this. So I'm just gonna use this string and just append the file that we want to load. So basically what we want to load is cube base material, and you can actually see that inside here. So I'm just going to show you. So cube base material dot 3mf. Okay, and that's it. Let's go ahead and run our program to see if we are indeed loading this model. I also need to go back to a build folder and run cmake again, since we added some code in our cmake file. Okay. Let me go ahead and put a breakpoint inside our read data function. So I'm just going to put a breakpoint here. Okay. So let me just step through this and just make sure that everything is good. So it seems this function is returning okay, and as you can see, the file name that we are passing is you can see the absolute path for this for this file, and after this we are returning okay. Great. So it seems like that our importer class now reading a 3mf file just fine. Okay, now before we continue, let me open up the 3D model of our cube based materials, and let's talk a little bit about what we are going to do in the next few steps. Okay, so I have the 3D model for our cube based material, as well as 3mf specification document open side by side, and let's talk about the model element first. So as you saw in the previous video, the model element is the root element of the 3D model part. Every 3D model dot model must have this element. In addition to that, every model must also have two additional child elements called resources and build element. Now let's take a look at build element first. The build element contains one or more items, and each item is basically the final output of a 3D object that we either want to visualize or 3D print. Each item also has an object resource ID that can be found inside the resources element. So if you take a look at the build element section, you can see that we only have one item in this example, and this item has an object ID set to 3. Now, if you go to the resources element, you can see that we have some other resources such as base materials, object of type mesh, and object of type components. Now, object ID 3 is referring to these object components, and we will talk about the components in later videos, but essentially they are just containers that are composed of other object resources, which allows you to have different instances of an object resource, and also they can reduce the size of the 3D document. Now, let's go ahead and talk a little bit about the resources element. You can think of a resources element as a collection of different resources that describe the final 3D object. For example, a resource can be an object mesh, it can be object components, or it can be a base materials in this example. Now, each resource might also rely on other resources for its complete definition. So if you take a look at our object mesh, you can actually see that it has some properties and attributes. And one of the properties is PID and PIndex. And this PID and PIndex are referring to another resource, which is basically a base materials. So PID1 is referring to base materials container, and the PIndex is referring to the color that this container has. Okay, now an object resource has a specific attribute or property that can apply to the entire object, or can also be overridden by a descendant element such as triangle element. So let me explain what I mean by that. So as you can see, our cube base material has only one color, okay? And every single triangle faces are using this same color. So it actually makes sense to have this PID and PIndex at the object level, which means that these properties are applying for all the triangles that we have inside the triangles element. Now, we could actually have these two properties like this at the triangle level. So again, these are the descendant of the object. So we could have it like that as well. But in this case, since we want this color, since we have only one color, we can avoid doing this and have these two properties at the object level. So I hope by now you can see the relationship between resources and build elements. Everything I just discussed can be found in chapter 3 and 4 of a specification document, and I highly encourage you to read it for more information. In this video, I'm going to simply skip the parsing of object components in the resources and build element for now, but we'll come back to it in future videos simply because later on we will be switching to using C++ style interface, and by the time we also have our OpenGL stuff set up, so we can actually visualize our meshes in our app. In the next step, we are going to add some code to parse the resources element and find a mesh object, and once we found it, we are going to parse some of its mesh information such as number of vertices and triangles, as well as vertex positions and triangle indices. In our import 3MF class, we are going to add some code to iterate through the resources element. The first thing that we need to do is we need a resource iterator and a flag. So let me go ahead and add this code. Okay. And simply what we want is we want to iterate through all the resources. So let's add this here. Okay, so I'm just going to call lib3mf model get resources, and I'm going to pass our p model as well as the p resource iterator. If everything goes fine, we continue, but if something goes wrong, we are just going to release the p model and p3mf reader. The next thing that we need to do is we need to iterate to the next resource in the list. So I'm just going to add this code here. So I'm calling lib3mf resource iterator move next, and we simply pass our iterator as well as the flag that we just defined. Now, the next thing we need is we need to keep iterating through our resources element. In order to do this, we are going to use a while loop. So I'm just going to use a while loop here. Okay. And inside this while loop, I'm just going to copy this iterate to the next resource in the list as well. So let's add this code again here. We are going to keep looping until this pb has next has become false, and we exit this while loop. Now, once we are exiting this while loop, we also want to release some of the resources that we have. So let me go ahead and add these codes here. So after this while loop, we are pretty much done, and we just release our resources, which is the p model, p3mf reader, as well as p resource iterator. Okay, now let's go ahead and print out the unique resource IDs for each of these object resources. So as you can see, our base material has a resource ID set to 1. There is another object resource that has a unique ID set to 2, and so on. So in order to do this, we need to get the current resource iterator and as well as getting the resource ID for that. So let's go ahead and add the code for this. Okay. The next thing is we need to get the current resource. Okay. So I'm calling lib3mf resource iterator get current, and I'm simply passing our iterator as well as this p resource pointer. Now let's go ahead and get the resource ID for this resource. Okay, so you can simply call lib3mf resource get resource ID, and all you need to do is pass the current resource as well as this resource ID. So after this, we can actually print out the resource ID and see what we get. So let's go ahead and see out our resource ID. Let me also include our iOS string. Okay, great. So let's go ahead and compile our code and see what we get in our output. Okay, so everything seems good. Great. So no surprise, you can actually see that the resource IDs that are being output are 1, 2, 3. Nice. Okay, so next thing that we want to do is we want to find an object mesh resource inside our resources. Now, to do this, we need a model mesh object pointer, which can simply point to the current model resource, as well as a flag to tell whether or not this object is actually a mesh object. So let's go ahead and add this code inside our while loop. So inside our while loop, we are gonna add another pointer called plib3mf model mesh object, as well as a flag called is mesh object or b is mesh object. Okay, now let's go ahead and check and see if the resource is actually in fact a mesh object. To do this, what we need to do is right after here, we are going to call lib3mf object is mesh, and we are going to pass our p resource as well as the flag that we just defined. Now, the next step that we want to do is we want to make sure that this mesh object is set to true, and the result of this is mesh object is also okay. If everything is okay, we are going to point our pmesh object to this p resource, and you see in a moment why we need to do that. And we pass this to another function that we are going to write in a moment called parse mesh object. So the parse mesh object simply is going to go ahead and print out the number of vertices that this mesh has, as well as number of triangles. Also, it's going to print out the vertex positions as well as the triangle indices inside this mesh. Okay, so let's go ahead and write our parse mesh object. Okay, so inside our header files, let's define this function. Okay, and let's go ahead and add some code to print out the number of vertices and triangles. Okay. So the first function that we are going to call is called lib3mf mesh object get vertex count, and simply this function is going to take a pointer to our pmesh object, which we are passing inside this while loop. So this is our pmesh object that we are passing to this function, and also the vertex count that we want to get or retrieve. Next, let's go ahead and retrieve the mesh triangle count. And again, you can call this get triangle count, pass the pmesh object as well as the triangle count variable. And after this, we are going to simply print out these numbers. Okay. Now, after this, I'm going to also assert and make sure that the vertex count is always more than 3. And also add another assert that says the triangle count must be more than 1. Okay, so let's also add assert, include assert.h, and I believe I made the typo down here, so this should be vert count. Okay, so now let's go ahead into Visual Studio and run our program to see what it outputs. And as you can see, vertex count is set to 8 and triangle count is set to 12, and that's what we expect. So great. The next thing that we want to do is we want to actually print out the vertex positions for each of our vertices that are inside this vertices element. So let's go ahead and add the code to do this. Okay. Now the first thing that we need is we want to have a vector of a model mesh vertex. And the model mesh vertex is simply a structure that you can find inside NMR model types.header. And as you can see, this header, this structure has an array of floating points, and the size is 3, which is for x, y, z positions that we have for each vertex. Now, I'm going to resize this array to be the number of vert count that we retrieve up here. Next, we gonna create a pointer to the first element of this array. So let's do this. Okay, I call it pvtx, and this is gonna simply point to the first element of our array. Next, we are gonna call this function called mesh object get vertices, and we are gonna pass our pmesh object our pvtx, which is the pointer to the first element of the array, as well as the vertex vert count and this new pn vertex count. Okay. Now let's check to see if everything is good. If it's not, we just simply return the h result. After this, I'm gonna also add an assert just to make sure that the new pn vertex count that we retrieve from this function is exactly matching the vert count that we retrieve up here. Right after that, we are going to use the for loop to go through all these vertices and print out the vertex index as well as the xyz positions. And right after that, we are going to simply increment our pointer to go through all the vertices and print out all this information. So let's go ahead and compile this code. Okay. I also need to include the vector. So let me just include our vector container. Okay, let's compile. Okay, everything is fine. Let's run our program. Great. So as you can see, we are printing the position for all of our vertices. If you look at our 3D model.model, you can see that we are printing all the positions correctly. All right. So let me close this. Now we are going to do pretty much the same thing for our triangle indices. Okay. So for the triangle indices, we are going to have a container of model mesh triangles. If you look at again at the NMR model types.h, you can simply see that this is also a structure which has an array of dword for the indices. So the indices that we are going to print are actually here. So if you look at the first triangle in triangles element, you can see that the first index for this triangle is set to 0, the second is set to 1, and the third one is set to 2. Okay, and we have different triangle indices for the rest of the triangles which we are gonna print out. So let's go ahead and add p triangle count. Again, we are going to have a pointer to the first element of the p triangles. Next, we are going to call lib3mf mesh object get triangle indices. And again, same signature. We are passing pmesh object, the pointer to the first element of the array, triangle count that we retrieved from here, as well as the new pn triangle count that we are going to get. I'm also going to add a new assert here just to make sure that new triangle count that we are getting is matching the previous triangle count that we retrieve up here. Okay, and again, we are gonna iterate through all of our triangles, and we are gonna print out the triangle index as well as the triangle indices. After that, we also gonna increment our p triangle and keep doing this until we've gone through all of these triangles that we see inside triangles element. Okay, so let's go ahead and compile. Okay, everything is good, and let's run this code. Great. So as you can see, we are printing out all of our triangle indices, and this should conclude part 2 of this video series. I hope to see you in the next video, and thanks for watching again.